Okay, now in this section I want us to look at the other dependent variable. Like let's look at the following variable, which is like V190. Okay, so this one is the worth index, and this particular worth index is in categories. We've got poor, poorest, middle, rich, and the richest. It means that when they were asking questions about this, they were looking at how old, and they were how rich. So somebody was we are determining it as poor, as poorer, as rich, as richer, etc. Now this particular variable is generated after taking so many indicators from different people, and then you categorize them like that. Okay, we call that one as a composite index, and normally you cannot collect it like this the way it is, but you generate it. So this was made from different variables that people were asked to do. Muli njinga, muli ngolo, muli galimoto, muli nyumba, muli TV, muli radio, muli what. So in the process they actually create a variable like this. The process is called principal component analysis. Principal component analysis is a process that people use to generate a variable of this nature. Okay, having done that, then you can be able to generate the index of this form. Okay, now so let's look at, if you have got a variable like this which has collected 4 categories which can either be derived, then you can be able to actually use it to describe the data. Now let's assume I should generate a worth like this, where is equal to V190. Okay, then I can tabulate where as that, when I know that 1, 2, 3, 4, 5 is in that particular order. So I can be able to tabulate V106 and where. Okay, so in this case, this is the descriptive statistics which I can have, and if I can be able to tabulate V025 and where, so this one is the place of residence that I can have. So let me just have 2 variables, okay, in that particular part. Then I can be able, because this is in category, I can be able to find the chi-square for these variables by taking CO, which is column percentage, and the chi-square. And then once you do this, it can give you the percentages and the corresponding chi-square for the values. And similarly, you can actually come here and then probability column percentage and then the chi-square. You can similarly have the results like that, so that when you're entering your descriptive statistics, you must be able to enter them in the right way. So make sure kuti mukakhala ndi categories angapo like this, descriptive statistics yake izionesa per each category. Don't group them together like kungo apanga without showing the categories, then that is very wrong. But you must be able to make sure that each level has the total as indicated, so that when you do this, then when you want to run the model, because it has so many categories like 1, 2, 3, 4, 5, then it is multinomial, either logit, m-logit. So you can actually say well, and from well you can actually put V025, okay, and V106. So you can be able to actually put it like that, and then when you allow the model to run, you can actually have the model for each. Now this one, it is always the one which has the highest number, it is actually being held as the reference category, so it cannot be seen. It is actually assumed to be 1. So it means that this is a model for the richer, this is the model for the middle, this is the model for the poor, this is the model for the rich. So you can actually now put the model side by side and start using them in that particular order. And similarly, if you want to look at the marginal effect for this one, then you can actually put like a MFX predict, and then you can say you wanted the probability of the outcome, this particular outcome 1. So you can actually have like that, and then you close. When you do this, it is going to bring you the marginal effect for the poorest, and you can be changing this particular where there is 1, 2, 3, 4, 5, so that instead you have got the marginal effect for each model that you want to have. So that's actually what the multinomial is all about. But in terms of interpretation, this particular Bayes is regarded as a Bayes model. So you are comparing all these other models against this particular Bayes model. So it means that this Bayes model is regarded as the standard, whereby all units at the standard are assumed to be 1, 1, 1, 1, 1, 1. So it means that for this one, it is less than 1. For that one, it is more than 1 by 0.88. It means that this particular model, it is for this one, it is worse off than the 1. For this one, it is worse off than the 1. But for this variable, it is better off than the 1. And similarly, you can be able to look at this particular part. This is even times 2 compared to the Bayes model, and this one is negative compared to the Bayes model. So that's the way you actually do. That's why multinomial, it becomes very complicated, because you must be able to compare the model against another Bayes. But sometimes you can decide to change the Bayes, only that it's not finalizing, it's still working. The computer is tired, it has so many things, that's why it is very slow. Now, so you can actually be able to change the Bayes. When changing the Bayes, umaika command apa, and you just say Bayes, then you specify the Bayes number. Remember, these 1, 2, 3, 4, 5, they become now the numbers. So in the part, you can actually now specify the Bayes. So when you are looking at the marginal effect, it has only given me the marginal effect for the outcome, which is outcome what? 1. But if I wanted the marginal effect for all, I would have put asterisk here. Asterisk is a star. If you put a star, it means that it can bring in marginal effect for all variables. Now, so you can change the Bayes. If you put the Bayes to be 3, and then you run the model again, you can see that the results, the Bayes model is going to be equal to 3. So that's the way you can be able to do Bayes. Then the one that got missed, it now appears. So this is actually how we actually work on the multinomial. So multinomial, it means that you can actually say you want to compare the outcome variable which has a category 1, 2, 3 in it. It can be maybe marketing channels, vendor 1, 2 maybe supermarket, 3 maybe field markets. So you can actually have 3 categories. So when collecting your dependent this variable, antuzega afusa asanke market imodzi bina matani amapanga prefer, inakasanka vendor market, inakasanka field market, inakasanka farm market. So ati ukaipangano tab izikaoneka ma 3 categories aja like one variable, then that one qualifies you to use it as a multinomial regression model. That's actually how we actually use this process. So make sure a multinomial, you can go through chi-square where you can compare different variables with its that is the factors against the dependent variable. But if the factor is but if the independent variable is not a factor, then you can use the t-test. You can use the t-test. to actually sort that one out. You can use the t-test. So on the t-test, you just say t-test, okay, then you can put the variable. For example, let me say in this variable, let me look for a common variable quickly. Look for children. Let me just look for children. Children, total number of children ever born. Okay, this one. If I can tab V201, you can see that children is in 0, 1, 2, 3, 4, 5. So I can be able to do t-test because I cannot do chi-square on this one. So I can actually say t-test 201 by, I can now specify by my dependent variable is where. Okay, when you do this, okay, okay, it is requiring that we have only 2 groups in this dependent part. Okay, then you can actually, in that way, then you can just use ANOVA this and that. Okay, okay, V201. Yeah, you can use ANOVA. Yeah, so that you can just know the difference between between 2 means. I think we will discuss more on this particular part, so that we should lightly classify how if a variable is continuous on this particular side can be related to this other side, so that we can actually know which one is which. We are going to continue in the next section for the sake of saving.